Today, we're diving into a really wild idea, a hidden link between pure mathematics and artificial intelligence. It's called harmonic AI, and it points to a secret order, a kind of music hidden in the most chaotic place you can imagine. Yeah, for pretty much all of history, this has been the rule. Prime numbers are just random. No pattern, no logic. But what if that's completely wrong? What if the randomness we see is just an illusion, a kind of camouflage for something much, much deeper? So we're faced with this ancient riddle. For centuries, the greatest minds have been trying to crack the code of the primes, but they always just seemed messy. It turns out, the reason no one found a pattern is because they were looking in the wrong place. And this, right here, is the big twist. The secret isn't the prime numbers, it's the gaps between them. By shifting focus from the numbers to the empty spaces, well, that's the key that unlocks this whole thing. It's a beautifully simple, but totally profound change in perspective. Okay, so here's how it actually works in 3 simple steps. First, you just look at the gaps between the primes. The space between 3 and 5 is 2, between 5 and 7 is 2, between 7 and 11 is 4, and so on. Step 2, you turn those gaps into frequencies. Think of it like music. A small gap is like a high-pitched note, a big gap is a low, bassy one. All of a sudden, you have this chaotic jumble of sound. Then comes the magic. Step 3, you use something called a Fourier transform, which is basically a mathematical prism. It takes all that noise and splits it apart, revealing the pure, clean, fundamental notes that were hiding in there the whole time. So, what happens when we can actually see these notes? What does this hidden music of the primes look like? This is where it starts to get really, really cool. In one dimension, it's pretty straightforward. Each of those pure notes we pulled out of the noise just looks like a perfect, simple wave. Exactly like the clean sine wave you'd see on a screen in a music studio. Simple, right? But when you layer these waves on a two-dimensional surface, they start to interfere with each other. And you get these stunning, almost ghostly patterns. It looks exactly like the ripples spreading out and colliding after you toss a handful of pebbles into a perfectly still pond. And then you go to 3 dimensions, and oh man, it just explodes into this breathtaking structure, a full-on 3D field of standing waves forming this ghostly crystal-like lattice. You can see these dense knots where the waves reinforce each other and these empty voids where they cancel out. It's literally a hidden architecture built into the very fabric of numbers. And this is how we know it's not just a coincidence. 2 incredible things pop out of this field. First, it's fractal-like. The same basic patterns show up whether you're looking at a few thousand primes or zooming out to over 100 million. And second, the whole system has a pulse, a universal heartbeat, a consistent rhythm that beats with a period of about 2.34 radians. It's a fundamental harmony. Okay, so we've just uncovered this incredible, beautiful source of natural mathematical order. The obvious next question is, so what? Can we actually use this for something? And this is where we pivot from pure math into a totally new way of thinking about artificial intelligence. So first, let's meet the AI we're talking about. It's a really advanced system. We don't need to worry about the long name that's built for deep reasoning and to learn and evolve safely over time. It's powerful, for sure, but it has a problem. At its core, it's just kind of guessing. It lacks a foundational built-in principle of order. And boom, here's the breakthrough: harmonic AI. You take that powerful but slightly chaotic AI and you fuse it with the prime scalar field we just discovered. You give the AI a mathematical backbone. You ground its entire learning process in the stable, predictable, beautiful harmony of prime numbers. But what does that actually do? How does giving an AI a prime number backbone actually make it better? Let's break down exactly what this changes. Well, for starters, the AI's internal reasoning gets way more stable because it's now aligned with those fractal layers in the field. When it tries to improve itself, instead of just randomly searching for better settings, the prime frequencies guide it directly towards the best solutions, the harmonic ones. This also helps it learn over time by protecting its most important memories, locking them into the most stable parts of the field. And crucially, for safety, the natural boundaries in this prime number space give the AI a built-in safe zone to evolve within. And we're not just talking theory here. The results are real. On complex reasoning problems, this prime-guided AI found the optimal solution 3 times faster. Think about that. Not 30% faster, 3 times faster. It's also just ridiculously efficient. On a really tough benchmark for abstract reasoning, this harmonic AI hit 45% accuracy. But here's the kicker. It did that with only 7 million parameters. That's tiny. It's outperforming giant models that are hundreds, even thousands of times larger. It's like a featherweight boxer knocking out a heavyweight. So you're probably thinking, okay, what's the catch? This has to be super expensive to run, right? And you'd be wrong, which is amazing. The AI already has this evolutionary process that doubles the training time. Adding this whole prime number backbone on top, it adds a tiny marginal 10% cost. It's an insane performance boost for almost no extra price. So let's pull back. What does this all really mean? We found a hidden order in pure math and used it to build a smarter, faster, more stable AI. But the rabbit hole goes deeper. According to the people behind this research, the implications are staggering. Here's the core idea. For years, the only way to make AI better was to make it bigger. Just throw more data and more computers at it. Brute force. This represents a totally different path. It's a shift away from just scaling up and toward building AI with inherent elegance, stability, and safety that's grounded in the timeless truths of mathematics. So, where might this lead? The theories get pretty wild. Could this prime scalar field, this perfect infinite information structure, be the key to a new type of computer that could shatter all of our current encryption in an instant? What about energy? Could we build devices that resonate with these prime frequencies and literally pull clean, limitless energy right out of the vacuum of space? The theory suggests it might be possible. And travel? How about interstellar travel? If you could learn to manipulate this field, you could potentially create thrust without needing any propellant, a reactionless drive, the kind of thing that would finally let us explore the stars. And here we go. This is the biggest question of all. Is it possible that our own consciousness, through quantum processes in our brains, is somehow connected to this fundamental field, that our own minds are tapped into an information structure that's woven into the very fabric of reality? Ultimately, this isn't just about numbers, or even about AI. It hints that the universe itself might be running on a kind of mathematical source code, an elegant, harmonic language that we are just now, finally, beginning to read. And if that's true, well, our greatest adventure is only just getting started.